After college, I started building software. So I started building software for medium, small-sized businesses. It was all web applications mostly. I would build frameworks, and all the pieces of software were data-driven. I started teaching at Clarkson. I started teaching undergrad courses at Clarkson, mostly in programming, Python, data, and data processing, data filtering, data transformations. When they started the data analytics program at Clarkson, I started teaching similar material at the graduate level. In the data analytics program, I teach 2 courses, one in the fall, one in the spring. The course in the fall prepares students for the beginning part of the data processing pipeline. So this is usually filtering data, doing basic aggregation of data, and also storing the data, how to store it in various structures so that the analysis process later on is much easier. In the second semester, in the spring, I teach big data architecture. We talk about using computing clusters to process data. We talk about many tools that can be used if the data sets become very large. So in many cases, you're dealing with data sets where you could have millions of rows, hundreds of millions of rows. And so in these situations, you need to have distributed computing, you need to have distributed data, because you can't fit it all on one single machine. Then we also touch in that course on environments. One of the really important things is to be able to take your project and the work that you've done to analyze data and give it to somebody else, or to take somebody else's project, a colleague's project, and bring it into your space and be able to work on it. And this is actually a really important thing, to be able to collaborate with people, to be able to give them your work, and to be able to look at other people's work. In the courses that I teach, programming is a big part of it. I think that one thing that's different about the way that I teach programming in the program is that I teach programming from a very practical standpoint. We use somewhat high-level language. We're using it as a tool, and it's really good for students to get an idea of a different way of thinking. Because if you come from even a math background, or maybe an analyst background without programming, you are really getting a tremendous value by learning a little bit of programming. So what I would say is, we've had students who come into the program, they don't have any programming experience, and they've gone out, gotten a job within that year, and they are one of the main people building APIs or machine learning algorithms, because they have just a little bit of programming experience. And if you can get just a little bit, it's very satisfying to accomplish something and to use that language to solve a problem. And usually there's a feedback loop at that point where you say, okay, I want to learn more of this because it's so useful.